Thanks, Recorded Voice. Hey, everyone. Welcome to Practical Motion with Constraint Layout. Today, I wanted to talk about this new library, Constraint Layout 2.0, that comes with Motion Layout. And I wanted to talk about really kind of like some actual practical techniques that you can use to build motion in your Android application. And to do that, I'm going to focus in on a new motion layout integration sample that we put together. This really was the product of a bit of brainstorming between John, Nicholas, and myself to kind of think about what motion layout really excels at. So motion layout, if you haven't heard, is an animation toolkit that's based on constraint layout. So it allows you to animate between different constraint sets that are specified using the constraint layout API. And it allows you to also, at the same time, while you're doing these animations, have very, very fine-grained control over basically every aspect of the transition between the starting and end constraint sets. So if you've seen constraint set animations, which we have on DAC and we made a dev bite about, this is very much the same concept, it's just taken a lot further. So the examples that we came up with when we thought about like what does motion layout really, really excel at compared to other animation options in the Android view system? We came up with a couple answers. Motion layout animations are always seekable. And this means that you can kind of jump to position 49 or position 75 in the middle of the animation. And motion layout will correctly jump to that location and display exactly pixel perfect what would happen as if you had actually run the entire transition there. So this is really, really helpful when you're trying to coordinate it with other views. So that's one of the areas where motion layout really, really shines. And you can see two of the examples that I have here, both the view pager on the left and the collapsing toolbar on the right, are actually having their animation driven by another view. Another situation where motion layout really, really shines is anytime you're basically showing a transition of state to the user. And the most common one of these is entrance animations for a screen. So you're transitioning from a previous screen into the full screen of a new screen. You could also use this for other transitions in your application. You could make an animation while you're have a transaction pending in a bank app, and then you could animate to something else when the transaction is finalized. Motion layout makes it very easy to express the start and end state for that in your code, and then be very specific about how you want to animate between those things. And you can see that in this middle animation here, where we're doing an entrance animation that basically goes from from empty and then scrolls into the rest of the screen. And I can see on my screen here that somehow the animation got cut off. It's supposed to keep scrolling through the space, but you see the basic idea of the animation in there. So for this talk, I'm going to break this into two parts. I'm going to talk about Motion Editor. I'm going to basically break down what the UI for Motion Editor is, because it's a big UI. It's a really impressive tool, but it is a professional, design tool that allows you to build, very polished animations. So as a result, it has a lot of UI controls. So I think it's very valuable to just kind of like demystify it. Let's take a look at what's actually in Motion Editor. And then after that, we're going to take a look at using motion layout in practice by kind of breaking apart those samples and taking a look at some of the really interesting things that were done in them so that you can apply similar techniques when you use motion layout. This talk isn't really kind of a beginner motion layout talk, though I do hope it's approachable to someone who hasn't used motion layout before. But I'm not also going to go super advanced either. So it's kind of like, maybe think about it as an intermediate talk. But if you haven't used motion layout before, hopefully you're going to get something out of this talk as well. So for Motion Editor, I want to focus in on this view pager example over here on the left. So if we take a look at this in XML, the way this is going to work is that's basically just a linear layout with a motion layout tag in it. And in that motion layout, there's an image view for the background and a text view for that emoji. That rocket ship is an emoji character. And then down below, we're going to have a tab layout and then a view pager. Right, so we can see like the different parts of the screen are represented in this XML layout file, right here and right here. So if we open this up in the Motion Editor, when we first click on down below, when we click on the view pager, we're going to see the attributes for the view pager show up in the design surface there. And if we click on the tabs, we're going to see the attributes for the tabs. And then when we click on motion layout, we're actually going to open up the entire motion editor experience here. So this is a completely different UI that happens whenever you're focused inside of a motion layout in the design surface. And there's actually quite a bit to this UI. I'm actually going to spend just a couple minutes walking through kind of the most important elements of this UI and kind of how to understand it when you're looking at it. It's a very usable interface, but it is trying to show such a complex topic. It's trying to show an entire animation to you visually in a way that's digestible and editable. So it does take a little bit of knowledge to understand what's going on with the motion editor. So when I look at the screen, there's just a couple large surface areas that we can see right off the top. So we have this design surface area here where we can see either the photorealistic preview like we're looking at here, or we can switch it over to blueprint mode and we can see the blueprint for the current screen. You can actually edit your animations in blueprint mode, or you can edit them with that photorealistic design. Then the most important panel in the motion editor is this overview area right here. So what this is going to do is it's going to basically give you, well, it's called overview because it gives you an overview of your motion scene XML file. So every major element in your motion scene XML file has a UI representation here. So we have the motion layout itself. So that's over there on the left. And then we have the start, which is a constraint set. This describes the constraints for the beginning of this animation. And we also have the end, which describes the constraints for the end of this animation. And this is fundamentally how you define an animation in motion layout. You provide a constraint set at the start, a constraint set at the end, and a transition between them. So the transition tells motion layout to figure out, basically by default, a linear interpolation between start and end for every single change that happens between those constraint sets. And we can actually modify that further, as we'll see in this example here. So you can click on all of these elements, and when you do, it will actually modify the rest of the UI. But before we move on, let's take a look at one last little bit. You aren't only able to use the UI display here. You can also display a list display using this little control up here. And as you build more complex motion scenes, this can actually be really, really, really useful. So let's dive in and let's select that start constraint set and see what happens down in the selection area. So the selection area is fundamentally driven by whatever the current selection in the overview panel is. So when I select a constraint set, it's going to display a constraint set display. If I select the motion layout, it displays the motion layout display. And if I select a transition, it displays a transition display. And in that selection area for a constraint set, I can see this little check mark right here basically tells me, did this constraint for this view come from some constraint set in the motion scene, or did it come from the layout file, or is it unconstrained? And then it's also going to show me over there on the right what the source of this constraint is. So there's actually, as we'll see later in this talk, different ways to get to a constraint set. And this is really, really helpful to understand, is this constraint coming from the start constraint set here, or is it coming from somewhere else? The other thing, the most important control on the constraint set area is this button right here. So this is basically the edit button for this. And when you click on it, you're going to get create constraint or clear constraint. And this is going to modify the constraints in the current constraint set for the view that you have selected. And then if we go and select the constraint set for background, it'll open up the attributes pane. Right, so all of these you can see as I'm selecting different elements in the motion editor, it's modifying the attributes pane. So the attributes pane at all times in the motion editor is going to display the current selection. And the current selection originally was just the constraint set. Then I selected the background, so now it's the constraint on background in the start constraint set. So that's what it's displaying here in the attributes pane. If I look in there, so on this page right here, we can see that we have all of the standard constraint set information that are all of the standard constraints, right? We can specify top, bottom, left, right constraints. We can put margins on them. We can set the height and the width. There's also a couple other things that are new in recent versions of Android Studio. We have this transforms panel, and then we also have for a motion layout, we have view transitions, which defines stuff about the animation itself. And then custom attributes allow you to specify constraints on literally any attribute that has a getter and a setter. One of my favorite things in here is definitely the transforms area. So we can click in there, and we can see that the transforms allows us to visualize the rotation attributes for Android. This is something I personally struggle a lot with. It's hard for me to understand what translation Y or translation X or translation Z means. And you can see really quickly visually as you're editing these what effect it's going to have on this view. And that will be, of course, represented in the final animation here as well. So next, I want to go ahead and take a look at the final UI surface here in the motion editor. And that's the basically when you click on a transition, you're going to get this transition selection. A transition selection displays a timeline. And it also, at the same time, because I've selected a transition, over in the preview area, it's displaying the motion path of the view, right? So we can see this rocket's actually following this little bouncy line here. And we can see the vertical line there for the background. And down in the timeline controls, we can, of course, we can play the animation. And when we do that, we'll see that Motion Editor actually plays the animation in Android Studio. And we can, of course, if this is too fast, we can slow it down. We can take it from 1.0 to 2.5. And when we do that, we'll see that the animation plays quite a bit slower. And this is really, really helpful when you're debugging a complex animation. It lets you kind of see it at a much slower pace, so you don't have to, kind of pay attention to every pixel as it's trying to be drawn really fast. If you want to get more precise than that, you can also just click on the scrub bar and drag to a very particular key position. And as you can see here, it's basically we're scrubbing through the animation and it updates as it goes. The other major control in the transition section is the same as with the constraint set. I have the ability to add new key positions, key attributes, key triggers, key cycles, key time cycle, which were in fact named after a sci-fi movie. So we're basically able to add any of the key attributes that we want to any of the things that we have in our transition. So here we could, for example, add a key position on the background and cause the background to move during the transition. And then finally, to finish the timeline, down here in the timeline, we can actually see we already have a bunch of key positions, and we have a key attribute. And they're represented by these little diamonds in the timeline. And we can actually click on one of those. And when we click on, say, the parent relative key position at 25, we can see that the attributes panel is going to display the display for that key attribute. And as we edit that in the over in the attributes panel, you can see over on the left that the preview is updating based on the current edit state of that attribute panel. All right, so final note on Motion Editor. This is maybe a little bit not obvious, but I wanted to be really practical today. Motion Editor is a very large UI. It takes up minimum half the screen, at least on my monitor. So I wanted to be very practical here and say that you should and can pull Motion Editor out to its own separate window. You can do that by just dragging the layout file that it's attached to, off of the Android Studio window, and you can move it over to a second display. I find when I use Motion Layout or any of our new Android Studio tools that use large UI surfaces, this is a much better way to interact with it, because I'm able to get my code for the motion scene over on my large primary display, and then I can use Motion Editor to preview it and make changes to it over on the laptop display as I have displayed here. The other big thing to understand about Motion Editor really is that it's designed to display your XML. Like the overall design of the entire thing. You saw this as I was talking about it. I kept talking about things that, if you know Motion Layout, we're directly talking about how a motion scene XML tag is represented in the UI. And this carries through in some pretty major ways. So for example, the ordering of your constraint sets in your motion scene file is the same order that they'll be displayed in the overview panel. The same with transitions. And you're going to see that the Motion Editor makes a really strong attempt to have a very high fidelity with the code. And you can edit the code over an XML. And I find that when I build Motion Layout files, I do maybe half the work in the Motion Editor and half the work over an XML. And it works totally fine to make edits over in the Motion Scene XML file and then reload them over in the Motion Editor. All right, so that's a good introduction to the Motion Editor. Let's go ahead and take a look at some Motion Layout practice. We're going to go in order of increasing difficulty for these samples. So we're going to start with this view pager example. So visually, if you look at this, it kind of looks like there's three states, right? There's three tabs on the screen right here. There's the list, there's the item, and there's the launch. But the way I'm actually going to represent this, just because it's a little bit easier to do the integration, is I'm only going to make a start and an end constraint set for this. So the start constraint set is going to have the rocket pushed all the way over to the left there. It's constrained to the start and to the bottom. And the end constraint set has the rocket pushed all the way over to the right. It's constrained to the top and the right. And also you can see that the background moves between the start and the end constraint sets. To get that middle position, what I'm actually going to do is I'm going to create a special keyframe in the middle that I'm just going to treat as if it was its own state. And it's going to be halfway between start and end. So it's going to be the 50% mark of this animation. So that's where the rocket's displayed there in the middle. And that's actually probably the most interesting part of the code for this sample is how did we get kind of this fake constraint set in the middle from a transition. And the way to do that really is to go in, the way to do that really is to go in and specify key positions and key attributes and various other keys on frame position 50, right? So I can actually say for frame position 50, I would like to make this rocket be 0.8% down the screen, or 0.8% down the motion layout. And you can see that now I've pushed the rocket down at frame position 50. Similarly, for the rotation, I'm just going to make a key attribute that does rotation of 40. It's also at frame position 50, and these things layer on top of each other. So now it's pushed down and it's rotated. And there's one more little little bit of a nuance that we need to do for the rest of this animation. If we look very closely at the animation between the first and second tab, we can see that the background's not really supposed to move until the rocket gets past item. So in order to do that, we're going to go in and make another key position for the background. And so basically all we're going to do is at frame position 50, we're going to say that the background should only be 5% along its path. So we're saying that even though the animation's halfway done, the background's only 5% done with its animation. So the net effect of this is the background's going to move very slowly for the first half, and then it's going to move the rest of the animation for the second half. So how do we actually do that background? That's probably another trick. This is one way to do it, and this way works pretty well for a lot of simple animations like this. The way to do this background here is to really kind of oversize the background image. So what I have here is I have a fixed 100 dp height, and then I have for the motion layout, and then I also have a layout height of a 300 dp for the background. Right, so the background's actually larger than the motion layout that it's in. So it doesn't fit. Like I have to like pan it around one way or the other in order to actually get some portion of the background to display. And then at the start, I can just say lay out the bottom of the background to the bottom of the motion layout. And that's actually going to push the background up, a little bit above the screen like this. And then at the end, I can say constrain the top of the background to the top of the parent, right? And that's going to move the background down below like this, right? So this is like a really simple trick to get kind of these scrolling background effects in motion layout. Now, I would mention this is a little bit less efficient than maybe doing some sort of matrix transform because it basically creates an oversized view, right? So if you have a huge background here, this might not be the right way to go about it. But if you're doing simple animations like this works totally fine. And it's a pretty good way to get started building this sort of animation in motion layout. Now, to actually integrate that with motion layout, what we have to do is basically transform the events from the view pager into something motion layout understands. So motion layout progress is always between 0.0 and 1.0. So this is kind of like a common task. I'm not going to focus on the math you have to do, but every single time I've had to build one of these for motion layout, the way to do this is to draw a diagram on a piece of paper, figure out what the formula inputs are, and then do some algebra until you figure out how you can transform, make a pure function that transforms from the inputs to 0.0 to 1.0. So here we're just taking the progress, which is the position plus the offset, and then we're dividing it by the number of items in the adapter. And if you go draw a diagram like that, you'll see that that always returns a value between 0.0 and 1.0, and it looks exactly like we have diagrammed on the screen over there. And then we can specify motion layout.progress, and we can just set that to this value that we've computed. And that's really the kind of the trick to these integrations, is figuring out how to take the thing the other view gave you and transform it into this 0.0 to 1.0 range that you need for motion layout. Okay, now I'm going to move on to my second animation that we're going to talk about, and it's this entrance animation. So it's playing the full thing here. And you can see that it's actually a very long entrance animation. So this one's actually kind of interesting because it's an entrance animation, I have a lot of freedom in time. This is not so true with the view pager animation. The view pager, because it was driving things, was asking me to transition from the start to the middle in, say 200 milliseconds, and I didn't really have any way to control that because the progress is completely controlled by the view pager. Now, since this is an entrance animation, I can actually make an animation. This one takes about 8 seconds to play the entire animation, which is a very long time, but the user important elements are on screen within a second. So this is kind of like one way you can sort of think about these entrance animations is you have a lot of opportunity to build more complex, more layered animations than you can for a view-driven animation. Now, one of the really interesting things about this animation is that despite the fact it appears to be a single animation to the user, it's actually a sequence of 4 different transitions between 5 constraint sets. And so this is kind of maybe not what you expect when you look at this, right? This is an example where the code doesn't really work the way the user might expect the code works. One thing that this animation also shows is how to use derived constraints. So we can see that down there on the bottom. Even though we have all of these different constraint sets, each of the constraint sets after empty derives from the previous constraint set in the animation. This is really, really helpful because basically it means I don't have to re-specify the constraints for every single view in the scene. I can build off of whatever the previous constraint set has done. So let's take a look at some code. Let's take a look at how we can do this derived constraint thing. So when we do this, so we have all of these different constraint sets over in our motion scene file. We have initial, we have empty, we have first half. And then when we get to first half, what we can do is basically say derive constraints from empty. And that's basically going to say whatever constraints empty had, if it came from the layout, or if it came from empty, or if it came from somewhere else, apply those as the starting constraints for first half. And then same for middle animations, it's going to take whatever constraints first half had and apply them as the starting constraints for middle animations, and the same thing for second half. So this means that anything I specialize in first half is automatically going to be carried through for the rest of this animation, which is really useful when I'm trying to chain animations like this. And one of the reasons to do this is it helps me kind of set up these keyframes that I might have gotten from my designer. So we can see that there's so I can see the derived constraints here on the screen. But in the motion layout, I can see the keyframes that I might have gotten from a designer. So I have initial, empty, first half, middle animations, and second half. And when I click on any of these constraint sets, the preview will jump to that location in the overall animation and allow me to tweak just that one area of the animation, even though some of them are very short. They're only maybe 100 milliseconds. And then down below in the constraint set area, we can see where the source is, and now we can see that it's different, right? The space emoji text and subtext is actually derived in the middle animations right there, but all of the other things are actually specified in second half. All right, so how do we actually build this big, long animation out of all of these transitions and all of these constraint sets? And the answer to that is this auto transition tag. So we already, because it's so fast in the animation, I ran through the first animation there right away. At the beginning, the constraint set was in this initial state, and auto transition, it was enabled to animate to end. So what motion layout did immediately upon loading this, this motion layout and motion scene was it immediately transitioned, it played the animation from initial to empty, and then it was in the state empty, which is the constraint set that it had just transitioned to. So now it's jumped over to this other transition, which is the only transition which starts from the empty state. So motion layout now sees that it's in this empty state, and it's going to note that this transition also has an animate to end on it. So because it sees that, motion layout's immediately going to play a transition. So it's going to run from empty to first half. And then once it gets to first half, it's going to continue on down and continue on down. So this combination of derived constraints and animate to end allows me to break apart and tease apart a larger, more layered animation and turn it into something that's a little bit more manageable in code, and I can understand little bits of it in isolation. The other thing, one of the big ones in this is I really wanted the effect of this animation to be that you were like launching into space, and then like as you got to the end, it like slowed down, right? So in order to do that, basically, I want the very last couple frames of the animation to be incredibly slow, but I only want the background to be moving, so the user can interact with the rest of the screen at this point. So to do that, this last animation, this middle animation, the second half, has a really, really long animation time. It's 7 seconds, which is kind of ridiculously long. And the motion interpolator is ease out. So this is basically going to come in fast and then slow down as it progresses through the animation. And then the last little bit of this animation is understanding how to get this kind of staggered build-in effect. As the cards come in, they kind of like fan apart a little bit, and then they come back together as the animation plays through. So in order to do that, it's very simple in motion layout. All you have to do is make a key position. So here I'm specifying card 1, and I'm doing that at frame position 20. And all I'm doing is saying %y 1.0, which says get to your final y position at frame position 20. Let me do the same thing for card 2, but this time I'm going to specify frame position 25. So it's just a little bit further along in the animation that card 2 gets to its final location. And then the same thing for card 3. At frame position 30, I'm going to go ahead and get to its final location. So as a result, because the views started packed together at the beginning when I pushed them down off the screen, because they end up at their destinations at different times, they have to spread apart on the during the transition on the way there. And that gets that staggered effect that we're going for. And that's pretty much it for this animation. There's a lot more of quite a few other key positions and key attributes in order to get the final total effect. But everything's pretty straightforward if you go check out the code for the sample. Interestingly, this animation here, this entrance animation, has absolutely no code in the activity. This whole thing plays entirely using motion layout. Okay, so next up, I want to talk about this collapsing toolbar. To me, at least, when I first heard about motion layout, like some years ago, my very first response was, that's amazing, I want to build collapsing toolbars with it. And it turns out it does work incredibly well for this use case, and I'm super happy to see that it came together so that we can use it that way. So the short answer to how to build a collapsing toolbar with motion layout is contained entirely on this slide. And if that was all I was going to talk about, the talk's done at this point. So all I have to do is take an app bar layout, just like I would with a normal collapsing toolbar. I make an on-offset change listener. And then I'm going to do another one of those transformers where I convert some other coordinate space into 0.0 to 1.1. And then I'm going to set the motion layout progress. And that's really all there is to this, right? This is all I have to do for a collapsing toolbar built with a motion layout. So now I want to talk a lot about how to build this particular collapsing toolbar and some of the interesting effects that you can accomplish with motion layout. So one of the things that, from the very beginning of this animation, we wanted to do something completely different. We wanted to do something that would be difficult to do otherwise, and motion layout allows to be possible. And we also wanted to do something that looked a little bit different than a normal motion layout behavior. And so we came up with this idea of using kind of this pop and teleport effect. So basically, we have this emoji, and it's going to pop out, and it's going to pop back in somewhere else on the screen. And there's not going to be any visible motion between the pop out and the pop in. So if you kind of think of the way that motion layout normally behaves, and we've been talking about this whole time, it's always creating these smooth curves between the start and the end that you can transform, and you're getting motion when you move a view. We kind of wanted to like get rid of that motion and and kind of create this teleport effect instead. Now, if you've been paying attention, you might know where this got inspired from. In fact, you've already seen this exact animation earlier in the slide deck when I displayed that right there. So this is, in fact, something that was inspired by a keynote slide. So let's take a look at how to build it in Motion Layout. So what I need to do in order to do this pop out, this is the really easy part. All I have to do is make a key attribute at some frame position. I'm going to pick 35 because that's where it fits really well in this animation. I'm going to scale to 0 both the x and the y coordinates. So that's just going to take the view and it's going to collapse it down to nothing basically. And then similarly, I'm also going to, because I want to stop that motion. I really don't want the view to move on the way to getting to frame position 35. I'm going to say that as a key position, that the %x and %y should be 0 as well. So this means the view should not move at all between frame position 0 and frame position 35. Another really important part of this, because we really want that discontinuous effect. We want the view to pop out in one place and then pop in another place, and we don't want any sort of momentum preservation from that transition. And if I kind of describe the visual effect of the curves that are generated by Motion Layout, they have the effect of creating the appearance of momentum preservation. And really, we want the view to show up with absolutely no momentum when it pops back in. So we're going to use curve fit linear, which basically is going to allow us to jump out and then absolutely no momentum, jump in, absolutely no momentum. And then over at frame position 36, which is literally the very next frame position in Motion Layout, all we have to do is use a key position there to set the %x and %y to 1. Right, so this literally says get rid of the view at frame position 35 and don't move it before frame position 35. And then at frame position 36, immediately move it to its final destination. Then we're going to go ahead and use that same curve fit linear, which is going to cause us to basically get rid of that momentum preservation effect that we really don't want to have in this animation. So the other interesting part about this collapsible toolbar is we went full screen. So now we have to start thinking about insets. And so to do that, we have to kind of talk about how does Motion Layout work inside of a collapsible toolbar situation. So one of the most I think surprising things is Motion Layout doesn't resize in a collapsing toolbar situation. So the Motion Layout's actually going to scroll off the screen when you scroll up. So it stays the same height the entire time. It just moves off the screen. And it's kind of your responsibility to figure out how to keep the views on the screen. And one of the best ways to do that is create a guideline that you can base off of the final destination on the screen. When we start dealing with insets, as we have to do here, because we're displaying that white circle underneath the battery and the network and all of that. So if we were displaying a white background behind that, it would be completely unreadable. So we're going to have to deal with insets. What we can do here is we can actually create 2 different guidelines. One for the collapsed top, which is basically just the top of the screen when the Motion Layout is collapsed. Even though it's not the top of the Motion Layout, we can base everything off this collapsed top and we keep our views inside the screen. Then I can actually get the insets from an inset listener. And I can set the inset to be the bottom of the inset in the collapsed position. Right, so I have these now 2 guidelines I can use inside of my motion scene or inside of even my constraint layout, my Motion Layout file, in order to position views based upon this inset. And then to kind of finish this out, I can also modify the start constraints inside of this set on apply window and set listener. So I'm going to grab the start constraints. This is the expanded constraints. And then I'm going to set the guideline in the start constraints as well. So as a result, these 2 guidelines now stay statically on the screen, even though they actually move inside the Motion Layout throughout the entire animation. So I now know exactly where the inset area is, and I can do whatever I want to display an inset background there. I can wipe it in like I'm doing here. I could have it, pop in. I could have it do some sort of fade in effect. But I have a lot of freedom now to position a view based upon this inset inside of Motion Layout. So the other really interesting part of this animation is definitely this circle thing that's going on. So let's blow that up. Let's take a look at that. So there's there's actually a lot happening in the circle area here. There's this ringed planet emoji that appears to be displaying below the collapsing toolbar, and then there's an inset circle there that it's displayed inside of. All right, so let's take a look at how that's actually implemented. So the first trick is this visual display is a complete lie. That collapsing toolbar actually extends all the way to right there. So that we're not actually pushing some ringed planet off of the collapsing toolbar. There's no like view clipping tricks going on here at all. We're actually just not displaying anything in about half of our collapsing toolbar. It's just a white background, even though that's part of the collapsing toolbar. And then at the top here, just the top half of this, we have this thing called cutout image, which is basically, it's just an app.compat image view that I'm going to specialize to do just these little bits of behavior that I want. And kind of the goal here is to really show how to integrate with some complex custom view from motion layout. So to do that, I'm going to define this bottom cut size, which is a float, which I'm going to make it a public property that anyone can set. They can set this bottom cut size, and that's going to cause the view to repaint. And I'm also going to set the end cut size as well. And that's going to describe the two different circles and their position. And then down in onDraw, I'm going to defer the drawing up to the parent. I'm going to let the bitmap view handle bitmaps. And then I'm just going to draw circles on top. So this is all I need to get the effect that I'm going for right here. So then over in motion layout, I can actually interact directly with this custom view, right? So I have this background, which is a cutout image. And in the constraint sets for expanded, I can specify the bottom cut size and end cut size and set the custom dimensions to be the appropriate DP values. So in the expanded size, I want the bottom cut size to be very large and the end cut size to be completely hidden. Similarly, in the collapsed state, I'm able to set the bottom cut size to completely hidden and the end cut size to 180 dp. And so kind of the big thing here is motion layout really allows you to interact with pretty much any get set pair on any view that you're able to that you want to animate, and you're able to build kind of smooth motion curves even for things that aren't actually moving views around the screen or changing alpha or stuff like that. All right, so where to go for some more information about this? So if you want to keep going, I highly recommend checking out the Code Lab and Sample. So the Code Lab's over there on the monitor, and it's going to walk you through the basics of motion layout and get you up to the point where you're comfortable with all of the different tools that motion layout provides to build animations. And the samples, the motion layout integration samples that I've been talking about today, show some basically real-world examples of how you might use motion layout to achieve everything from very simple effects that are very easy to add to a screen up to much, much more complex layered effects that you should work with a motion designer to build. And then one final note before I go off stage, there's 2 more talks coming up on motion layout. We have one by Nicholas and John coming up right after me, and that one's going to be great. I saw one of the demos that John put together for that, and it is really cool. So I recommend checking that out. And then Hwen's going to be giving a talk about practical constraint layout later today that honestly I've been looking forward to since I heard she's giving it, and I can't wait for that one as well. And I highly recommend everyone check that out. So thanks everyone for coming, and I really enjoyed seeing you today.
Thank you. I will allow everyone to unmute themselves and ask questions. Go ahead.
Hello. Oh, there's lots of questions in here. Let me start with this question about similarities between motion layout and Macromedia Flash. That's actually a really good insight. So if you know another animation tool, you're going to find a lot of similarities between motion layout and another animation tool. So there's a bunch of, I use a couple because I'm in DevRel, so I actually build a decent animations. I use a couple different animation tools, and the core concepts of animation are pretty stable. And motion layout really took a look at some of the best animation tools out there to try to figure out how to build the motion editor, how to describe motion using XML. With the net result, we wanted to build a programmer's tool, not a designer's tool. So we really wanted to focus in on creating a tool that produces XML that you can check into source code repositories, and that's how you're describing your motion files.
How do you envision the motion editor working with Compose?
That is a question. Honestly, I'd recommend you ask that to John and Nicola. But my answer is I think we're going to be able to do some really interesting things in that area. So two answers there. One, Compose has a different transition-based animation layout system. And so there's work on a different animation tool in Compose to visualize and interact with a transition definition that's a pure Compose transition definition. So I think that work is going to probably be very fruitful, and hopefully we're going to get some really cool tools out of that. Similarly, there's ways to get, if you restrict some of the API surface, there's ways to get Motion Editor to interact very well in Compose. But that's all code that hasn't been written, design docs that haven't been written at this point. So I'd highly recommend giving that question to John and Nicola to get some of their thoughts. There's a question about like repeated code in the motion scene. Yes, this is real. I'm not gonna like I'm not gonna say that this isn't real. So the specific question is like, do I have to repeat the height and width and constraints of every view? So if you specified the XML in the pattern that I did, then yes, you do have to specify all of those attributes over and over again. And luckily, the motion editor makes that very easy. When you add a new constraint set, or a new constraint to a constraint set, it's going to copy the old attributes and allow you to modify them. So in the visual tooling, it's actually very easy to manage all of these things. But over in the XML file, it does generate quite a bit of code. There is a way to break that apart. There's another XML format that allows you to override just one part, such as like the positioning or the sizing, and you can use that form structure. And if you're writing only XML, I'd recommend checking that out because that's probably going to be better for you, just in terms of maintainability and code readability.
How does this work with like different like layouts? Like, let's say like portrait and landscape. Well, if you have like a UI that looks different on landscape versus portrait, what do you have to do? Do you have to like display with different XMLs, or how does that work?
Yeah, no, that's a really good question. So two answers. You can just do. I mean, it's the same problem you have today with just non-motion layouts. So you can either, if you want basically the same thing, but you just want to hide a view or something like that, or maybe change a guideline or something like that. You can just do that, by modifying constraint sets like I did in the inset listener. So you can actually encode when you're figuring out like your screen size or something. You could go ahead and modify your constraint sets off of like some key guideline that you're moving around or something like that. But if you want a completely different animation, you have a couple options. You can actually load constraints from different types of files. So you can set this derived constraint tag I had has a lot more options than just using derived constraints from inside the current file. So that's a good way to get started on this. And then you would follow the same pattern you do today in the view system, where you use layout resources to branch based on the width. Robert asks about the swipe handling API to handle the view pager thing. So I had this view pager example, which showed a rocket ship moving across the screen. And he asked, can you build that view pager using, or can you build that same effect using the swipe handling? You can, though what you would then be doing is you'd then probably be controlling your view pager from your rocket ship. So you basically be turning your rocket ship into your tabs. I don't know, it totally works. In that case, you'd have to build 3 constraint sets instead of 2. But yeah, you could build that visual effect if you really wanted to, and completely replace that tab layout with a motion layout. Any other questions, or I can stay on the call for a little bit if anyone wants to chat some more.
Thank you. That was great. Really informative.
Thank you. Alrighty, I'm gonna I'm going to head over to the chat room. I'll be on for the rest of the conference. I'll be on the chat room. So ping me there if you have any questions, and I look forward to seeing what you build. If you have a chance to try to tweet it out on Twitter, I love seeing what people build with motion layout. Thanks. Have a good day.